this is the Datablast 2.9 new features preview. Ignite your operations with our new firing module. So we'll be going through a couple of different items for this particular presentation. So we'll be going through burden check, custom properties, scale depth of variables, and firing range. So my name is Sophie Mellor. If you haven't met me before, I am a Rio Tinto mining engineer and a certified QM. I have been with Datamine for about a year, and I most commonly work with a series of product suites in the Studio range. So that's Studio RM, Studio OP, NPVS, and Datablast. So we have several different divisions in our Datamine mining branch. We have exploration, geology, planning. We are currently operating within the planning division. We also have production, laboratories, and sustainability, just if you haven't seen the full scope of our products before. The drill pattern in front of you is a 89mm 4x4 meter staggered bench blast with a design angle of 15 degrees and a 10.35 meter depth. The pre-split holes are 89mm holes spaced 1.5 meters apart with an angle of 15 degrees and a depth of approximately 10 meters. I'll be using this pattern to demonstrate our new Drill and Blast software version 2.9 beta. Before I take you through the burden check, I just want to show you the location of the relevant settings. So the settings are in Site Maintenance, drop down Mine Site to Mine Site Settings, and then in the Advanced Settings tab. So as we're doing a FlyRock tutorial today, you can find all the FlyRock settings at the top of the Advanced Settings panel. So we have minimum design face burden multiplier of 25, minimum check burden multiplier of 19, maximum burden multiplier of 25.5, a charge density scale factor of 0.5, and a FlyRock factor of safety of 2. So I will activate our particular pattern and edit it in Designer. Okay, so I'll give you an example of the inputs you require for a burden check. You need a face surface and face holes. So we will be prepping the face surface first. So CAD tools, I'll have a look at the actual face. The face is this little area on this particular block. I will render this just to give you an idea of the pit we're actually designing in. So the area we want is this little face surface here. I have just cut that face surface, just using cut objects, just activating and deactivating the show surface collar in order to select the appropriate items. So now we have our little face surface. We can click back over to burden check, select that as our desired face surface, hit enter, just so you can see that the orange is now perfectly matching with our topo. I will select face holes. Hit enter. And I will now calculate our face burdens just to see how we're going. Okay, so we have, if you can see over here, we have 2 green, couple of blue, and the large multitude of red holes. So I'll review them each. I'll just scroll through. So this is our first one starting from the left. So it is a red, so we'll need to adjust that hole slightly. We've got 2 greens up next, so they're perfectly fine. They're within the correct distance from the face. A4, A5, and A6, our next couple of holes, and A7 are blue, so they're a little bit further away from our face than is optimal, but that's fine. And then from A8 to all the way down to A27, they're all red, so they'll need adjusting. And you can actually see the maximum distance is 2.27 in this case and 2.22. And we are currently at, for A27, we're currently at 2.01. And it's fairly similar for all the A's all the way through to A8. So that just gives you an example of how far you have to shift your holes back from the face. So I'll just exit the face burden review, have a look at our holes, and I basically want all the holes from hole 7 onwards to just be adjusted. And I just want to shift these holes by 0.2 in the Y direction. And then I will recalculate the burden check just to see if that's changed anything. And you can see a lot of the holes have come up green. So I'll just deal with the couple of extra red holes. And then basically here onwards. And as you can see, they've all come up green now. So with a couple of minor adjustments, you can greatly reduce your risk of fly rock. You can even, with a couple of clicks, do a burden report and get a printout of all your different face holes. So yeah, you can then just print them out or save that as a copy on your hard drive, just to give an example that you've helped to minimize the fly rock risk. Okay, so with that burden check, we'll simply move on to the next one now. Custom properties are calculated values. These generally take the form of unit conversions, for example from imperial to metric, or coordinate conversions, for example from local grid to mine grid Australia, MGA. This allows you to export data in a format that is meaningful for both the drillers and their drill systems and to conform with government regulations. So in this example, we have design collars and design toes with MGA coordinates associated with them. This just allows us to export mine grid Australia. Okay, so I'll show you where the custom property definitions are located. Mine site, custom property definitions, and this gives you a quick overview of all your custom property definitions and associated calculations. So we'll just give an example custom property. It'll be on mine site variable. So this will just be a parameter, LG to MGA. Description is set the local grid to MGA for chosen parameter A. We'll do this as a decimal, and it'll be a user editable property value. We'll then add a second custom property just to give an example of a calculation. So this will be called design collars LG to MGAX. That little warning lets you know that the name you've chosen actually has another variable in the database that's identical. So that's why I'm adding an E on the end, just to give you an example of how to change a name ever so slightly, and you can then add it to the database. LG to MGA property grid description is design color MGAX. In this case, it's a decimal and a calculated expression value. I'll hit edit expression. You can hard type it in, or you can actually find the variables you're chasing in your drop-down menus. In this case, I've just hit Control V, and that's given me the expression I'm chasing. So I'll just hit apply for this one, and apply. So that's giving you two example variables. So I'm just going to hit Save Changes, exit Mindset Maintenance, and then I will go to Settings, Custom Properties, and here I have a set of dummy values, essentially, just so that I can do all my calculations for this tutorial. It's just listed a whole bunch of LG to MGA conversion numbers. We can enter 10 for our new one that we have just attempted to define. We've also got a whole bunch of MGA to LG parameters that are not currently in use, but they are also in the system. So you can define whichever values you like, and then add in numerical numbers associated with them. So I'm just going to hit Save Changes here. Exit Mindset Maintenance. So now you can see that we have our little example here, just under MGAX. We've added a slightly different value, so it's giving us a slightly different number to the original, but that's fine. So if you would like to export these variables, you simply come up to Utilities View, Export Data. I have previously loaded a template called Custom Example, but it doesn't actually have any of the new variables that I would like. So in this case, you can just drag and drop the variables you would like into your template. You can double check that the numbers have come through with a little preview down the bottom. In this case, I've only got D14 selected, but if I close this and select all the holes and hit Export Data, make the same selection, you will get a full list of all the holes coming through for this particular pattern. And you can double check all the variables and that they have new numbers associated with them. And you can just hit Export Data. You can then save your pattern that you have recently designed. And then you can double check that all your variables have come through, and you can either send this particular pattern to the drills, or you can hand it over to the shop firer, whichever you prefer. You can even give it to government authorities, simply because it now has a whole bunch of MineGrid Australia calculations associated with it. So if you, similarly, this is a Australian example, so it is coordinate conversions, but you can do very similar examples, for example, between feet and meters, or any other metric to imperial conversion that you would like. For the sake of brevity, I have skipped ahead in the tutorial to the initiation module. So scale depth of burial and exclusion zones. Scale depth of burial is an empirical measure of blast energy confinement and can be described as the ratio of the stemming material to the amount of explosive within a space equivalent to 10 times hole diameters. That's from Tobin, 2013. As a rough guide, a scale depth of burial of 0 to 0.9 is a crater blast, and it's characterized as violent fly rock, air blast, noise, and dust with very fine fragmentation and good craters. 0.9 to 1.4 is a controlled blast with good fragmentation, maximum volume of broken rock in collar zone, acceptable vibration and air blast, and good heave and muck pile mound. 1.4 to 1.8 is a very controlled blast. You have coarser fragmentation, reduced volume of broken rock in collar zone, reduced heave and muck pile mound, and no fly rock. Whereas 1.8 to 2.4 is a minimal surface activity blast, so small surface disturbance or insignificant surface effects. So basically, as you go higher with scale depth of burial, you generate less surface activity, less air blast, less noise, less heave. So it's just a measure of the amount of explosive energy centered around your particular drill holes. So in order for me to demonstrate the scale depth of burial features in this particular module, I'm going to skip to our new firing module. And then I'm going to add a firing pattern. So as you can see, the firing pattern is empty at the moment, so I will have to select all these holes and add initiation pattern to our new firing pattern. So that will generate a whole set of firing holes, and you can basically see that scale depth of burial has actually been hard-coded into this program because we have a number of different toggles. Down the bottom, I am then just going to hit Save Changes. And I am going to authorize use of a firing pattern. You can then click these little toggles down below and show hide scale depth of burial. And that'll give you the scale depth of burial for each of the holes. This is technically a minimal surface activity blast. It's a very, very safe blast. We've got a scale depth of burial of 2.4 for this particular blast. You can also show the fly rock range expected. So its range with the factor of safety that we have previously entered into this program is 59.71, and you can give the fly rock circle range with the factor of safety. So that gives you an idea of the distance that these holes can send fly rock. You can also click up here and create fly rock safety boundary if you would like a demonstration of the maximum range of this particular blast. So that's a quick demonstration of the scale depth of burial and exclusion zones for this particular design module. The final topic for this webinar is the online help. So you can access the online help by clicking on the Datablast logo and then going down to the help option. The Datablast online help has various methods to search. You can use a standard drop-down tree list, for example, initiation module, initiation patterns, and it'll bring up a series of text and images. Towards the end, there are also quite often videos, so you can actually watch videos of people who have created these patterns in the past as they go through and demonstrate. The videos are very easy to access. You just click on them and you will get a pop-up and the video will almost immediately start playing. You can also use the interactive search. For example, it will simply search all the available modules in the online help menu and give you the results. So if you want to run a burden check, it'll give you a step-by-step example on how to run a burden check, and you can actually navigate through the different trees by clicking at the top to find videos. So in this case, you've got a fly rock control and a burden check video. So I'll click on the fly rock control video just to give an example of how the videos work. A lot of them are located in Vimeo, and then you just hit play.
Drill and blast teams are under enormous pressure to consistently deliver safe blasts.
So that's just an example of a previous video that was done for FlyRock, but the entire help menu can be navigated in a pretty simplistic method. There is training for new users if you want the training modules as well. Down the very bottom there is a glossary of terms and a series of videos if you're looking for the hyperlinked videos. Alright, thank you very much for attending this tutorial today. Very much appreciated. Have a great one.